Yeah, so we are all are connected now from the different part of the world. So, Professor George, how's the weather there in New York?
Snowing.
So, is it much better or like it's too cold?
It's pretty cold.
It's pretty cold.
Yeah.
Is it better in Chicago, Professor Compiari, or?
I don't think it can be worse than here.
Is really that bad today or?
Yeah.
It's
And Professor
pretty,
Kim,
it's
how's at Pittsburgh, the weather? It's relatively cold or?
Yeah, it's cold and it's really great today.
Yeah. Yeah, so I think we are on time. So I think we shall start now. And we are also going live on the YouTube. So with your permission, shall we start? Yeah. Yeah. So ladies and gentlemen, good evening to those who have logged in from India, Singapore, and Europe. And good morning to those who have joined us from the US. My name is Shivam Srivastava, and I am a researcher in the area of marketing and innovation at the Center for Business Innovation at Indian School of Business, Hyderabad. We are delighted to welcome each of you to this insightful panel discussion organized in the webinar format. Today's discussion delves into one of the most widely debated and transformative topic which is happening these days, which is the invisible hands of AI reshaping online search, advertising, marketing research, and consumer behavior. Artificial intelligence is revolutionizing the digital landscape, subtly yet profoundly influencing how we search for information, engage with advertisements, conduct market research, and make purchasing decisions. This session brings together leading experts to explore the far reaching impact of AI, uncovering both the opportunities and challenges that it presents for businesses, consumer, and society at large. Our esteemed panelists, each a distinguished experts in their field, will share valuable insights and on the evolving intersection of AI, management, technology, society, and culture. Through this discussion, we aim to deepen our understanding of AI's transformative role and explore its implication for the future of digital ecosystems. So before we begin the discussion, may I kindly request Mr. Venkatesh to introduce the aims and the current initiatives of CSITM. Over to you.
Sure, Shivam. Good morning and good evening. I'm Venkatesh Balakrishnan. I manage the Center for Software and Information Technology Management at Indian Institute of Management, Bangalore. On behalf of IIM and CSITM, I extend a warm welcome to the distinguished speakers of today and all the participants. Professor Shankadeep Banerjee is the chairperson for this center. I would give a 1-minute introduction of the center for the benefit of those who are joining our event for the first time. CSITM is a center of excellence in digital technology management in IIM Bangalore, and this has been in existence for about 25 years. We all know that Bangalore is the IT hub of India, so due to its locational advantage, CSITM maintains close connections with the large IT companies in IIM Bangalore and many of the places in India as well. And over the decades of its existence, it has developed contacts with academics, professionals, lawmakers, and all government officials around the globe. And the goals of this center is to promote knowledge exchange, training, conducting workshops, promoting research, and we conduct various events. Some of them are in the format of webinars, such as the one that we are having now, and some of them are large events in the form of conferences. As we speak, we are getting ready for a large summit under the title Software Product Management Summit India, which is to be held by the end of this month. And I request all the participants to look for announcements from the center and actively participate in all the future events. And with that, I hand it back to Shivam to take the event of today forward.
Thank you so much, sir, for your introduction. It is now my pleasure and privilege to introduce our esteemed panelists who have joined us for this exciting session. We are truly honored to have them with us today. I will just briefly introduce to our panelists because if I would do in the detail, it will take another webinar. So just briefly introducing to our esteemed panelists. Our first panelist is Dr. Min-Kyung Kim. She is an assistant professor of marketing at the Tepper School of Business, Carnegie Mellon University. Her research interests lie at the intersection of quantitative marketing and empirical industrial organization. Specifically, she explores workforce management, including areas such as sales force compensation, job design, and workforce diversity, as well as consumer platforms engagement, focusing on aspects like online review posting. Dr. Kim earned her PhD in marketing from the Yale School of Management and holds a BBA and MS from Seoul National University. Before joining Carnegie Mellon, she was a faculty member at UNC Kennan Flagler Business School. Our second panelist is Dr. Giovanni Compiani. Dr. Compiani is an assistant professor of marketing at the Booth School of Business, University of Chicago. His research focuses on quantitative marketing and industrial organization, with a particular emphasis on applying advanced methodological to analyze consumer and firm behavior. Dr. Compiani's work has been published in leading academic journals, including the Journal of Political Economy, the Review of Economic Studies, Marketing Science, the Journal of Marketing Research, and Quantitative Economics. He earned his PhD, MPhil, and MA in economics from the Yale University. Our third panelist is Dr. George Zidagui. He's an assistant professor in the marketing division at Columbia Business School. His research leveraged causal interference technique and behavioral economics to study consumer behavior in digital marketplaces with a primary focus on e-commerce and online grocery platforms. Dr. Gui is also broadly interested in enhancing predictive machine learning models and Gen AI by integrating causal inference and economic theory into their development and application. Our fourth panelist, Dr. Samuel Goldberg, couldn't join the panel today due to his health conditions. And, uh, and so we'd like to welcome all of you to this forum and outline the structure for today's discussion. Each panelist will present their perspective for 15 to 20 minutes, followed by a panel discussion. The panels has agreed to take questions from the audience at the end. So please feel free to type in your questions as and when they arise. The sequence of today's panel will be as follows, which is Dr. Kim, Dr. Kompiani, and Dr. Gui. So without any further ado, it is my great pleasure to invite Dr. Kim to share her invaluable insights and expertise with us. Over to you, Dr. Kim.
Thank you. Yeah, let me share my screen. Okay, so can everyone see my screen?
Yeah,
Okay.
perfect.
Okay. Very good. Okay, so thank you very much for having me today. So as introduced, my name is Min-Kyung Kim. I'm an assistant professor of marketing at Carnegie Mellon University, Tepper School of Business. Today, I'm going to share my research with Isamar at HBS, Ishita at Wisconsin Madison, and Suyeon at USC on the impact of unionization on consumer perceptions of service quality, evidence from Starbucks. As you can see from this title, AI is not the main focus in this research question, but it's actually indeed an invisible hand to shape this research as aligned with today's theme of this webinar. because AI tools and generative AI tools are helping us analyze customer sentiments and to facilitate market research. So let me elaborate what I mean by this. Unionization is a major trend across industries right now. Workers are pushing for better work conditions, better wages, benefits, and wages and benefits. And 28% of new unionization petitions that are filed are from the hospitality industry, which is largely customer facing. And especially for businesses in this kind of industry, unionization is not just an internal matter. It can directly affect customer experiences and customer perceptions. So the big question we are tackling here today is, does unionization impact customer experience and satisfaction? So far, most studies have focused on labor outcomes like wages, turnover, and productivity. And they have showed mixed outcomes. But customers have been largely understudied. So our study investigates the unionization's impact on customer satisfaction and specifically through service quality. And service quality could be impacted by many sub-attributes. So what aspects of customer experience change the most? So unionization could affect employees' morale. So employees' friendliness could change or affect productivity, which affects service speed or timeliness, which altogether affect service quality and customer satisfaction. And instead of relying on surveys, we turn to AI-driven review analysis to find this answer. So traditionally, businesses use surveys to gauge customer sentiments, but surveys could suffer from low response rate and high cost, as we all know. So that's why we use real-world customer reviews from third-party platforms like Google, which have millions of data points and have high credibility than company-initiated or union-initiated surveys. And another good thing about this third-party platform is that they use the same format or layout across the businesses or across the restaurants. So it's really easy for us to compare the unionized and non-unionized stores in terms of the customer sentiment. But here's the challenge. There's too much data. Manually reading and analyzing reviews is almost impossible. Some scalability is the key. So that's where the AI comes in here. So we use natural language processing to extract the attribute level insights. So not just for overall star ratings, for overall restaurant experience or Starbucks experience, but the attributes that customers actually care about, like food or service or ambience. So our study asks two research questions today. So does customer satisfaction change after a store unionizes? And if so, which attributes drive this change? Is it service speed or employee friendliness or store ambience? Our setting, empirical setting is Starbucks. One good thing about the Starbucks is its standardization. As you know, every store has the same menu, same products, and the employees go through the same training. So it allows us to identify the causal effect of unionization. And in Starbucks, the unionization movement started in Buffalo, New York in 2021. Just to give you more specifics, each store makes its own decisions to join the union or not through some kind of votes within each store. And as of February 2023, out of 16,000 stores in the US, 467 stores have filed to unionize, and 371 stores voted in favor, and 84 voted against the unionization, so could not be unionized. As you can see from this map, the unionization decision was not really centered on some kind of locations. It's very across the nation in the US. And our data include store-level union status, union vote timing and location, and customer reviews on Google. And we matched these two data sources by using the store addresses. So our final sample is 1.9 million reviews from around 15,000 stores from 2021 to early 2023. So what happened after unionization? A quick plotting of the raw data tells us that the average star ratings seem to drop after this red vertical line, which is the unionization timing. But as you know, this is not causal. This is just an event study. And the main challenge in the causal inference is the selection into unionization. Is the unionization decision is not random. Each store decides whether to participate in the union or not. So that's where the empirical challenge comes in. So we use two approaches. First, we use an instrument that leverages exogenous differences in each store's access to union resources, which is proxied by the physical distance to the NLRB offices, which is the National Labor Rights Office, which protects the right of the private sector employees to form the unions. And also, second, we limit our analysis to those stores who voted for unionization only, although some of them ended up not being unionized and others got unionized. And regardless of the approach, we see the average ratings drop after the unionization. So let's go deeper. What's driving this change? To understand this, we turn to AI-driven text analysis. We borrow the framework proposed in my earlier paper with Ishita and Sudhir. So we basically extract attribute level ratings from text using BERT at sentence level. So what's the sentiment for food quality, store ambience, and so on, especially the timeliness or the service speed, and employees' friendliness or the employee behavior, and the general services. So we tried to see that if the sentiment is negative, neutral, or positive, and we aggregate these sentiments at the sentence level, across the sentences to have a sentiment at a review level. So let's see how the attribute level rating changed after the unionization. So here, the dependent variable is the probability that a customer writes a negative review about each attribute. So the positive coefficients mean that the customer was likely to write more negative reviews. And what we find here is that the sentiment didn't really change for food or location or the store ambience, which is consistent with our expectation because of this standardized menu and food in Starbucks. But sentiment around employee behavior got worse. Specifically, compared to pre-union levels, it's about 14% increase in negative reviews. So we can see that the service quality, especially through the employees' behavior, drove the change in the customer sentiment about each Starbucks store. And one challenge with this text analysis is the training data. Sentiment analysis usually relies on human-labeled data, but this is slow and expensive. So what we are trying to working on right now is to augment training sample with ChatGPT. So we are combining human-labeled data, 1,800 samples, and ChatGPT labeled data, 2,100 samples. And we are not trying to compare the accuracy at this stage, but here the point is generative AI tools can potentially augment human work by saving time and improving insights. So going back to our research question and the result, the mechanism of rating drops is not really the scope of this paper, but we can get some idea from the previous literature. So past research suggests that companies resisting unions can create some kind of hostile work environment and impact employee morale, which would negatively impact employees' friendliness or the employee behavior to customers. And this is actually what's going on with Starbucks right now. The Starbucks management do not really like this unionization movement, so trying to have some kind of retaliation take retaliation actions to the stores. Although we cannot really verify this is the main reason. So the main point is we wanted to show that the market research assisted by AI allows us to analyze real customer sentiments at scale, and generative AI tools like ChatGPT can efficiently process unstructured data by augmenting training data. And this is how we could study the change in customer sentiment after unionizations. So in other words, I think like AI-driven market research can potentially change the way businesses understand their customers, and it's a fascinating opportunity for all of us. So that's it for today. Thank you.
Thank you so much, Dr. Kim, for an insightful and data-driven exploration of how unionization impact consumer perceptions of service quality. Your research, leveraging AI-driven sentiment analysis and text-based attribute extraction, provides a novel perspective on labor's movements and customer satisfaction. Thank you so much. So now I would like to request Dr. Giovanni Compiani to share his thoughts. Over to you, Dr. Compiani.
Thank you very much. Can everybody hear me and see the screen?
Yes, yeah.
So thanks, Shivam. Thank you everybody for tuning in. Today I want to talk to you a little bit about a project that is joint with two co-authors, Ilya at Northwestern and Stefan in London at Imperial. So in this project, we aim to propose excuse me, a method for estimating demand with text and image data. So let me give you a little bit of background on what this is, sort of the landscape that we are operating in. The demand estimation is a key building block in many social sciences and marketing, in economics, in finance. And what I mean by demand estimation is basically a way to estimate substitution patterns. So how consumers substitute from one product to another as the relative prices of different products change. So as an example, take tablets, which is one of the categories that we're going to look at down the stream. And we might want to ask, how does the demand for a model, a specific tablet model, let's say iPad 9, change as the price of another tablet model, let's say the Amazon Fire 7, change? This is what I mean by substitution patterns. How closely the consumers perceive these products to be, and as a result, how much do they switch from one to the other as their relative prices vary. This is obviously of interest to the manufacturers of tablets in this example, Apple and Amazon, to the retailers that sell these products, and that might want to set the retail price or their assortments, and to researchers in marketing and economics that want to use a demand model to make predictions about what the effects of a tariff could be, for example, or of a merger between firms, or might want to give firms suggestions as to, for example, optimal pricing. So the standard approach in this literature is to model the utility that consumer I gets from product J, that I'm denoting UIJ, as a function of the product attribute, right? So we're basically saying two products give the consumer similar utility, similar enjoyment, if they have similar attributes. So in the case of tablets, if they have similar, let's say, memory, similar storage, similar resolution, similar, let's say, color, richness and vividness, and so forth. And so this is the standard approach that has been sort of used in the literature for decades now, and it's kind of a workhorse model to estimate demand. However, this approach faces a couple of challenges. So one, we need to decide what these attributes are, right? So in this case, these attributes I'm denoting by the letter X are basically, again, the memory, the resolution, the price of the tablet. And you can imagine if you want to scale this approach up to many categories, you have to make a judgment call for each individual category as to sort of what are the relevant attributes in that category. Tablets are obviously very different than toothpaste, and so for each different category, you would need to make a similar choice. The second potential challenge is that there are categories for which this kind of traditional numeric attributes just don't capture a lot of information. So for example, imagine an example like clothing, or art, where the visual aspect, the style aspect is kind of crucial to the product. In these cases, we might want to go beyond traditional numeric attributes and leverage information coming from, for example, the image of the product. And so this is what we're trying to do in this project. So we propose to use two sort of novel sources of data, text and images. And let me just walk you through an example to sort of illustrate this. So imagine, again, with a fashion example, imagine that some of you might be shopping for dresses, in this case, women's dresses. And we might want to use images as a source of data, so which obviously convey a lot of information about the style of the product, of the dress. We might want to look at product titles. And in this example, the titles already contain quite a lot of information about sort of the type, the nature of the product, the characteristics of the products, including, the length of the sleeves, the type of neck, the pattern that the dress has. We might also want to look at product descriptions. So this is how the sellers describe their own products. And again, here we might want to extract information about sort of, in this case, the number of pockets that the dress has, or even sort of the other kind of clothes or accessories that the dress can be paired with for a good look. So what we do in this project is propose a methodology to do this, to incorporate this type of data coming from text and images into demand estimation. And the first step of the approach is going to be to process data, the unstructured data, so the text and image data using ML, so machine learning approaches. And this is sort of the connection to the theme of for today's talk. We then proceed to validate the approach. I'm going to walk you through an experiment that we run to show that sort of this approach captures consumer substitution patterns in a successful way. And finally, we're going to apply this to many categories on Amazon.com. So the empirical framework is in a way, very simple. We basically convert text and images into lower dimensional objects, which are called embeddings. This is just a term used in computer science to mean numerical representations, lower dimensional representations of things like text and images. And then we're going to use these embeddings to model, again, how similar two products are. Our source of data is going to be, again, images, descriptions, and also reviews and Q&As. So these are more user-generated sources of data, of text data. Just kind of walking you through the main models that we use pre-trained models. So these are machine learning models that are have been trained for classification purposes mostly. Let me start with images. So these are actually available for use online. We use something called the Keras Deep Learning Library, and they're essentially deep learning models that are targeting a classification problem. So they are designed to be able, if I give the algorithm or the machine learning model an image, they're designed to give an answer as to what object that is. Is this a cat, or is this a dog? Is this a butterfly, or is this a car? What we want to do is related to this task, but not exactly, right? We're not so necessarily interested in classification per se, but we're interested in sort of understanding similarity across products. And so what we do is basically we remove the last steps of the model, the classification layers, and extract the numerical representations of the products, again, the embeddings. So just to give you an example of how this works, in this example, for the VGG model, you feed an image, let's say in this case, the image of a car. The model kind of reduces the dimensionality of this object through different steps. And then there are a few steps here towards the end. I don't know if you can see my cursor, but towards the right of the plot that perform the classification step, that basically use the numerical representation of the product to say, is this a car or is this a dog? Again, we're not necessarily interested in classification per se, so we very simply remove the last few layers that perform classification and extract the numerical representation, in this case, a 512 dimensional representation of the product. Just to give you a sense of how this works, here I'm showing you 4 earbuds, which is one of the categories that we're going to look at. I'm showing you focal items in the first column, and then the items that the approach says are closest to the focal item in the space of embeddings. And as you can see, the model sort of does a pretty good job at capturing things like color, whether the earbuds have, wires or are wireless, and whether they have a case or not, and also brand, right? So most of this last row for item 4 is Apple earbuds, and the other ones are for different brands. We do a very similar thing for text. Again, the idea is basically to turn these text data into numbers, into lower dimensional numerical representations, again, embeddings. And we use a few different models, some of which are very, very simple, bag of word models that essentially just count the co-occurrence of words into text, let's say into reviews. And on to more complicated models that don't just look at words in isolation, but look at sentences, and so try to capture meaning in a more nuanced way. And then the second step, so once we obtain these embeddings, we essentially plug in the embeddings into a standard ML model, very much like the one I showed you at the beginning of the presentation. Essentially, we're gonna from a sort of technical point of view, we're going to put a random coefficient, so a beta I coefficient, a coefficient that is heterogeneous across consumers on the embedding to capture the fact that different people might have different valuations for the different characteristics of the products. One wrinkle is that these embeddings, as I showed you before, are still quite high dimensional. They can be as high as 500 or even 1,000 dimensional. And so we further perform dimension reduction via principal components. So we reduce the dimension of the embeddings further via PCA, and we get in the empirical applications that we're going to talk about, we're going to get 3 embeddings. And then we include those modified embeddings, which I'm calling E tilde here, into the model. All right, so this is a model that sort of makes sense intuitively, but how do we know that this works? We're going to validate this model via an experiment where we recruit around 1,000, just shy of 10,000 participants on Prolific. And we asked them to choose among 10 books. We picked books from Amazon bestsellers list. The books are of different genres. There's some sci-fi, there's some or more like fantasy, some self-help, some thrillers. We randomize prices to make our life easier in that way. And we ask participants to make 2 choices. First, they're going to choose their favorite book among the 10 books that we show them. And then we ask them to choose again after removing their first choice. So we basically ask them to choose their second favorite book. And what we're going to do is we're going to use the task 1 data, so the first choice data, to train our model, to estimate our model, leaving out the second choice data from the estimation. And then we're going to validate our model on the second choice data to basically really capture how well the model does at predicting substitution patterns, at predicting what consumers would choose if their favorite product was removed, which is, again, very close to the notion of substitution pattern as I described at the beginning. So just to give you a sense of the interface, again, we ask, this is just the top of the page. They can scroll down and see 10 books. For each book, they see the image, the book cover, the title, the price, the genre, year, number of pages, a description that they can read, as well as 5 customer reviews from Amazon. They're going to choose their favorite book. So, for example, in this example, the participant chooses the first book, Don't Believe Everything You Think. If that's the case, then the person will have to choose again from the remaining 9 books. And this is going to be the second choice, which again is used for validation. So how well does our model do at capturing these patterns? Well, we have the results look like this. So the first row, plain logit model over here, this blue dot in the first row, is sort of a benchmark model that really does non-model at all the similarity across products and is known to do a poor job at capturing substitution patterns. And as you can see, this model has a pretty high second choice root mean squared error. So this is a measure of error. So a larger number means a worse model. And so we want models that have a lower error. So the first row is sort of our benchmark that is known to not perform very well. Our favorite model, which is based on text, particular reviews in the second row, in this orange dot, reduces the root mean squared error by a substantial amount, by essentially almost 0.09 down to below 0.07. And as a comparison, in the bottom part of the panel, you can see how well we do if we forget about the unstructured data, if we forget about the text and images, and just use the traditional product attributes to model substitution. So the price, the number of pages, the year of publication, and the genre. And you can see that if we try different models that sort of have random coefficients on different attributes, we improve over the benchmark model of Logit, the first row, but still we don't do quite as well as when we extract information from reviews in the second row. So this tells us that the traditional approach improves a little bit over, or meaningfully over, the Logit benchmark, but still there is some additional information in unstructured data, in our case in reviews, that is predictive of consumer choices. This is sort of a way to validate our approach, but again, it's a lab experiment or an online experiment. Ultimately, we're going to want to deploy this approach in the field in observational data. And to do this, and also to showcase sort of the scalability of the approach, we apply this to several categories in online retail. So I'm not gonna spend too much time on the details. There's much more in the paper, but we basically use Comscore data, which is a panel of consumer behavior online. So we see people going on different websites. We focus on Amazon.com, and we record what they purchase in different product categories. We match this with the price data from a different source, and we're going to estimate essentially our demand model in many different categories. So as an example, with tablets, we extract information from the product image, the title of the product, the description of the product as shown in the Amazon product page, and then we also look at product reviews. We collect the first 100 reviews for each product. And just to give you a sense of the sort of what the model does, again, in the case of tablets, I'll show you here a matrix of elasticities, of price elasticity. So the way to read this matrix is basically, let's focus on the first column. This says what happens if the price of Fire 7, which is one of the Amazon tablets, increases by 1%. And of course, we would expect the demand for Fire 7 to go down if the price increases. And this is what this first number says, negative 0.6 says. We expect for a 1% increase in the price of Fire 7, the demand of Fire 7 to go down by 0.6%. What about the other tablets? The other tablets are gonna gain, right, because their competitor is more expensive now. And what's interesting is that the model does a pretty good job at capturing sort of the nuance of these gains, right? So there's some tablets like Fire HD8, which is quite similar to Fire 7, that are going to gain a lot from this increase in price because they are very similar to the focal tablet. Similarly, iPad 9.7. And then there are some tablets like the Fire 8 Kids or the Dragon Touch, which are very different. They target different demographics, which still increase their market share a little bit, their sales a little bit, but to a much lesser extent. And so this is really the sense in which the model does a good job at capturing substitution patterns in a nuanced way and breaking what is known to be a negative property, undesirable property of standard models like Logit, the independence of irrelevant alternatives, or IIA, which would basically say all these numbers would be the same. So Logit is a very restrictive model because it would essentially predict that these numbers should all be the same, which is really not what we were expecting, not even what we see in the data. This model does a good job at sort of capturing this nuance and breaking this unrealistic pattern that is imposed, that is really baked in more standard or more restrictive models. Just now to show you how this plays out across many categories and which sources of data matter the most. Here, again, we try around 40 categories, ranging from video games to pet food to other electronics or even household supplies. And you can see that, and what I'm showing you here is a Kaike weight. So basically, this is how the different sources of data, images, titles, descriptions, reviews, the extent to which they are predictive of substitution patterns. And so you can see there's quite a lot of heterogeneity. So for some products, like some video games or things like tablets, actually, images are quite predictive, or the most predictive source of data here at the top. But then we have for other products, let's say electronics media players, it turns out that reviews are much more informative. What we conclude from this is that there's a lot of heterogeneity across categories, as we would expect. It's somewhat kind of hard to predict exactly which source of data will be most predictive. And so our recommendation is actually to try them all and perform model selection. And we have more to say about this in the paper. We essentially recommend looking at which model fits the data best, accounting for the number of parameters that the model has, and then go with that model for the subsequent analysis. Just to wrap this up, again, we proposed a way to incorporate text and image data in demand models, which we validated in an experiment, and then we showed how to apply this and what the results are across many categories in online retail. There are many questions that we think this opens up. One is we used off-the-shelf ML models, but we could actually imagine fine-tuning the machine learning models, so the mapping from the text and images to the embeddings to improve on performance. And so this is actually where even more modern AI methods, for example, transformer models, and the deep learning, for example, behind LLMs could be interesting to apply. And then we're interested also in pursuing and applying this to sort of different empirical applications that are relevant, like predict the effect of mergers, and working on the econometrics behind this approach, which is I didn't really talk about, but there's some interesting econometrics questions that this raises. So thank you very much for your attention, and I leave the floor to the next speaker.
Thank you so much, Dr. Compiani, for your insightful presentation. Your research shows how using text and image data can improve demand estimation, giving us a better understanding of how consumer makes choices. By applying machine learning models, you have demonstrated a new way to analyze product demand beyond which is from the traditional methods. Your experiment and real world application on Amazon products, which you demonstrated, make this research even more valuable for businesses and researchers alike. We truly appreciate your time and look forward to seeing how this work develops in the future. So we will delve deeper into your presentation during the Q&A session. So now it's time for Dr. Gui to share his presentation with us. Over to you, Doctor.
Thanks, Shivam. Can you hear me? The internet on my computer was a bit unstable, so I'm connecting through the phone. Can you hear me?
Yeah, we can hear you. Yeah.
Great. Okay, let me share my screen. Thanks again for inviting me to this amazing webinar. What I'm going to talk about today is a project that I'm co-authoring with my colleague Olivier Tubia on the challenge of using large language model to simulate human behavior, a causal inference perspective. So before getting started on the challenges, I want to first talk about the promising and the potential of using large language model to simulate human behavior. Large language models have demonstrated some very impressive potential to simulate human behavior across different applications, such as behavior experiments, market simulations, preference estimations, and also other applications. So if we can simulate realistic human behaviors using large language model, then the implication is substantial for researchers as well as for firms. For researchers, it's going to be more effective in testing theories and hypotheses about human behavior, and even conduct difficult or impossible real experiments, because sometimes there can be cost issue and other times there can be ethic issue. For firms, it means that they can design and test new products, services, and strategies very efficiently, understand consumer preferences and behavior, predict market outcome, and evaluate policy and regulation impacts if the simulation is realistic. So in fact, many firms have already started to offer large language model-based customer insight services. For example, here is one example where the firm's saying user research without the users, which sounds fantastic if the research is accurate and realistic. This is another example where they're saying we survey AI copies of your customers to build finance-friendly sales and marketing plans in minutes, not months. So this kind of highlights the potential and the value of being able to simulate realistic human behavior using large language model, because it's going to be cheaper. It's also going to be faster. So the question is, is it accurate? How can we make it accurate? And what are some of the challenges and solutions that we need to think about along this direction? So what we were trying to highlight today is about the ability for large language model to simulate human counterfactual behaviors, because this is what many firms and researchers are interested in, what's going to happen if we change the treatment while holding everything else constant. For example, what's going to happen to sales if we increase prices? What's going to happen to the ad if we frame the language differently or change the picture, or what would happen to the market if we introduce a new product. So the ability to simulate counterfactuals, like how well this large language model do, what are the challenges and solutions. So this is going to be our key research questions in terms of what are the challenges, what are the trade-offs, and how can we improve the experimental design practice for large language model simulations, because this is a new area. An obvious question is how much should we use the established experimental design practices? What are the key differences, and what are the opportunities for us to innovate on this area? So I want to talk about the challenge by starting with a very common practice that has been done in the field in using large language model to simulate human behavior, is that it's often based on a blinded between session design that mimics the traditional between subject experiments, where each subject is a new independent large language model session, and different sessions will expose to different prompts, or you can think about it as a treatment. And then we compare the differences. For example, here is a example of a blinded design where we are asking the LLM, please consider you're a customer, please consider the following product category. Suppose you're in a store and you see the product, and the product is priced at a certain value. Would you or would you not purchase the product? So if we randomize the price, the question is, can we replicate the demand curve or simulate the demand curve? So the empirical context we're considering is we are thinking about demand for 40 popular CPG products across 40 categories, and we varying the prices from 0 to 200% of the regular prices. And the core stimulation approach we're considering is to tell GPT you are a customer, and then describe the purchase scenario and ask for purchase decisions. And we have some specific details that in the paper that we can share later if you're interested in knowing more of the technical details. So this to illustrate what are some of the challenges, this is an example prompt that we're using. So in this example, instead of asking for the purchase decision that customers may experience given the price, we are asking about their history. So please, we're asking them, given different prices, what is the last time you purchased the product? So the reason that we're asking is that in regular experiments, we should expect that the treatment you're receiving will not change the pre-treatment variable. And the pre-treatment variable can include customer history and some latent and stable things that won't be changed. But the question is, what about LLM? And it turns out that pre-treatment variables that are supposed to stay constant are subject to change in LLM simulation experiments if we are not careful. So this is a example where we are comparing the price. The x-axis is the price that we're randomizing, and the y-axis is the past price of the customer, of the simulated customer. And we see that there's a clear positive correlation. And this is just not limited to past price. It's also related to competing price, the price of the competing products. It can also be related to the expiration dates of the products. There can be some unintended associations if we randomize the price. And in hindsight, this is not surprising, because in real observational data, prices of different products can be correlated. And an LLM trained on such data naturally will make this association. So this is the naturally occurring association that is present in the training data, and there's no specific instructions that kind of instruct the LLM to not leverage this association. And whether this association is useful depends on the research goal. If we're interested in prediction, like the competing price given the focal price or the past price given the focal price, then it's performing really well, but it can be potentially bad for causal estimation if we have some like thought experiment in mind, like hope to change the treatment while holding everything else constant. So this is like one particular issue with the large language model using to do the simulation. And what's going to happen for the demand curve if we're using the large language model to simulate it? So here is a comparison of the large language model simulation of the demand curve versus the human, where we are surveying about 1,000 customers and asking them the same questions. So here, if you look at the green, the blue line, you find that this is an example of potential endogeneity generated by, like, if we're looking at like the demand curve of observational data. You see that there is an area where there is an upward sloping demand curve, which is very unusual for CPG products. And if you look at the human survey result, you see that it's a downward sloping one. And it could be potentially driven by the fact that for GPT, they will also infer not only the focal price of the product is going to be low, but also the competing product is going to be priced low, and also the consumer's purchase history that the price they experienced in the past is low. So like the pre-treatment variable that are supposed to remain constant are subject to change in the LLM simulation setting. What are some of the potential solutions? Now, like one, if you're familiar with the observational approach in the causal inference, then one obvious reaction is like, can we specify more detail to control for those variables? And this is like, there are like examples like a silicon sample approach where we can create synthetic personas with very detailed, for example, demographic informations to define them and then change the price. So to control for those variables that we worry will change. So like, can that solve the problem? And then after we create a persona, we simulate the purchase decision and then aggregate across the distribution of simulated personas. And the key question is, which variable should we include? Can we specify all relevant details? And does adding detail introduce new biases? Because like if the conditional independence assumption in the GPT simulation holds, then like it is possible that we can identify the effect of interest in observational data. But the question is, what about like the LLM simulation? So here is the illustration that shows that adding additional demographic information indeed helps. Here you see a comparison of the ground truths and the demographics. It's better than the vanilla version we had before, but there's still some areas where you see that there is upward sloping curve, which is not plausible. But the bigger issue is that first, it's unclear like what kind of variables you want to control for. And second, if we're including more variables, there is also a possibility that it's going to make those variables that we're specifying artificially salient to the simulated customers. So what I mean by that is that this is an example where we're simulating the demand for Coca-Cola and we're controlling for the competing price. And once we are including the competing price, we find that the demand curve is downward sloping, but is implausible in the sense that customers will purchase if and only if the price is lower than the competing price. So in other words, like it seems that the competing price is used as a reference point, but this is not realistic because in real life, customers are inattentive. It's not realistic for them to like pay attention to the competing price all the time. And if we look at the demand curve within a real store, we shouldn't expect this kind of demand curve. So in other words, like if we're including more detail, it's possible that some of the details will be made treated as artificially salient to the simulated individuals. So this is like the potential issue. The next question is, can better models fix these issues in the future, right? So what we have shown is one specific examples for one specific model. So the obvious question is, what about like future models? So we're going to claim that the challenges are unlikely to be fully resolved by merely improving the model or like fine-tuning or RAC. And the reason is that one of the key issues lies in the ambiguity of the problem or ambiguity of the instructions that we're providing. To illustrate the question, let me give an example of like a causally ambiguous prompt that we are asking the simulated individual to answer. So let's say you were saying you're a customer who has recently read an article about how sugar consumption affects health. You're now in the store and you see a regular Coke priced at a certain price with a soda tax. Would you purchase the product? So this prompt, like if you're a researcher, you have certain questions in mind that you may interpret in a certain way, but if like for LLM, it can be like very ambiguous, and even for us, it can be very ambiguous in terms of like what is the treatment that we're interested in, and what are the covariates. Because if it's a treatment, it means that it should be randomized and should be uncorrelated with other pre-treatment variables. But if it's covariates, then it's used as a control. And also, like, what are the factors that customers are supposed to consider when making decisions? We have mentioned the soda tax. Does that mean that the customer should be hyper attentive to the soda tax? So this is a causally ambiguous prompt because it's unclear what kind of causal questions we're trying to answer. And if we're familiar with the Duke calculus, we know that like when we are thinking about like different treatment, the answer are also different. So in this context, it can be price as a treatment, health information as a treatment, sugar content as a treatment, and the answers to those questions are going to be different. So we also have a theoretical theorem that shows that like as long as the prompts are ambiguous, like no large language models can correctly answer all questions. But like due to the limit of time, we will not dive into the detail. But here I want to give you like a high level visualization to think about the problem. So ideally, like researchers may have some counterfactual causal questions that they want to answer. And they want to simulate a data that has the format like this, where you have observables, you have the treatment, and the treatment is affecting the outcome through certain realistic mechanisms. So this is the ideal experimental data set we wish can like mimic or simulate. But if the prompts are ambiguous, it can be unclear what kind of data set we want to simulate. From the LLM's perspective, one possibility is that the LLM may mimic observational data. And this is very plausible, especially given that most of the LLM is trained on observational data. So unless there is some specific instructions for it to leverage experimental data, then like even though originally we were interested in simulating experimental data, then LLM may return some observational data. And like one of the potential solutions that we discussed before is to control for covariates. So this is like the conditional independence assumption. But the issue is that typically when we're using the controlling for covariates, the data is already collected, the data generating process is given, and then we don't modify the data generating process. The issue with large language model and the simulation of controlling for covariates at the data generation stage is that it's possible that it can change the data generating process. And in our context, it can change the data generating process in the sense that it can make, for example, the variables that we're including artificially salient and therefore like change the mechanisms that we're studying. So it may generate some experimental data, but the mechanism is not that realistic anymore because real consumers, when they're making decisions, they can be inattentive and they may not pay attention to everything. So it can sacrifice the ecologic validity of the simulation. So now, like, what are the potential solutions? Since like one of the big challenge is that the prompts can be ambiguous. It's unclear what kind of treatment we're studying, what variables are covariates. One potential solution is through unblinding. So we're deviating from the standard practice of blinding because that in the context of LLM, blinding has some additional negative downside. So one possible solution is to communicate the experimental design to LLM. And here we are demonstrating one way to implement this, where we are asking LLM like as an expert in consumer behavior to predict the experimental results and with the detailed survey. And then we see that this is the results, and it is still not perfect, but it is better than the results that we had before. Now, of course, we're not saying that you have to do this, you have to implement this way, but like the key consideration that we want to have for using large language model to simulate human behavior is that you want to make the scenario that you're describing like unambiguous from a causal perspective, and there are different ways to implement this. But of course, there are potential caveats of this approach, at least when we are evaluating based on the current model. So this is one potential caveat, is that the experimental design will change the results. Here, what we're showing is what's going to happen if we say that we are running a survey that has different range of prices that we're randomizing. So the red one is the original one of the prices that we're randomizing. And then we also have a blue one and the green one that only randomize a subset of prices. Now, in normal experiments, if holding the population the same, we should expect these lines to overlap. We shouldn't expect that the range of prices to affect the outcome, but we see that here the result is still sensitive to experimental design. So there are still some caveats of this approach. Even if we're not using additional validation data, there is some issue with the consistency. But there is no specific reason why this issue cannot be resolved in the future empirically, unlike the issue that we're pointing out about ambiguous prompts. So ambiguous prompts is something that, no matter what kind of models you're using in the future, you cannot resolve it, in the sense that as long as the prompting strategy you are using is ambiguous, you cannot answer all the questions correctly, no matter how good your data is and how advanced your modeling technique is. So this potential limitation could be something that can be improved by future model. And this is an example that we're exploring, where we see that we're using more recent models, and we see that the gap is becoming smaller. So to summarize, the key findings that we have identified some fundamental challenge in blinded simulation experiments, where treatment can affect unspecified pre-treatment variables, which created some unintended associations that resembling the observational data. So the simulated data may resemble observational data because of this. And the trade-off in simulation that we want to consider is that if we are including a lot of detail, we may sacrifice ecological validity because customers may be hyper attentive to those details. But if we're not including details, we may sacrifice on confoundedness. And that is something that cannot be fully resolved by better models alone. So a promising direction is because the challenge is that we are having ambiguous prompts. So we should consider avoid ambiguous prompting strategies and also consider unblinded design, which is quite unconventional from a traditional experimental design perspective, but helps avoid this ambiguity. But overall, taking a step back, it also points to the opportunities for designing a new set of simulation best practices, which may differ fundamentally from human experiments. So that's all I have. Thank you so much.
Thank you so much, Dr. Gui, for your insightful presentation on the challenges of using LLMs to stimulate human behavior, particularly from a causal inference perspective. Your discussion on the limitation of observational data, the complexities of counterfactual reasoning, and the potential biases in model training provided a valuable insights. Your emphasis on bridging the gap between AI-generated prediction and the real-world decision-making was especially thought-provoking. We truly appreciate your time and expertise in shedding light on these critical issues. And if I may ask the first question to you, Professor George, that the creation of detailed synthetic personas has been suggested as a way to improve the realism in LLM simulations. However, does incorporating demographic and behavioral constraint risk introducing new biases, such as overfitting to certain consumer archetypes while overlooking emergent behaviors? And how we can ensure that synthetic personas maintain both diversity and unpredictability, mirroring real human decision making in dynamic market conditions?
Yeah, thanks. That's a great question. So, so you're asking about if we are incorporating detailed persona, when we're simulating behavior, how to can I interpret as how to make sure that the simulation behavior is realistic, especially along the dimension of diversity and also other behavior bias, or are there other particular aspects you're interested in?
No, no, in fact, you got it wrong. So, like in diversity, if we talk in that concept, and the more I would say, like emergent behaviors and unpredictability.
Um, Yeah, so I think that's a great question. Like ultimately, one key factor depends on whether we have some procedures to kind of validate and verify, and like to kind of summarize other certain caveats or biases of our simulations. So we're Olivia and I are actually actively working on another project where we're like it's a follow-up project where we're collecting like more detailed information about consumers and see like whether using a subset of questions how well we can predict others. So I think that can be a valuable procedure for us to evaluate and evaluate whether there are certain cases where we're not doing well. Yeah.
Yeah, thank you so much, Dr. George. My second question is for Dr. Kim, talking about the concepts and the context of perception versus reality in post-unionization service quality. So your findings suggest that a decline in in customer satisfaction, especially in employee behavior ratings. So could this be driven by perceptual biases influenced by media narratives or ideological views rather than actual service changes? Or have you analyzed linguistic shifts in reviews to distinguish between tangible declines and pre-existing biases towards unionized labor?
Yes, that's a great question. So, given the interest of time, I could not go to that direction, but we did the analysis on the linguistic styles and tried to extract the keywords related to the unions or like some kind of like political or ideological sentiments toward the unionization. And we removed those samples from our analysis samples to make sure that this customer satisfaction or the customer perception is mainly about service quality. But we acknowledge it that it's like impossible to completely rule out that explanation, but we tried our best.
Yeah, thank you so much, Dr. Kim. My third question is for Dr. Kompiani. If your methodology integrates text and image embeddings into the demand estimation model, addressing challenges in traditional characteristics-based approaches. Given the deep learning models like VGG19 and sentence bird capture, different types of semantic and structural information. So, how do you ensure that the embedding extracted from these models align with consumer decision-making patterns rather than reflecting algorithmic biases? And could this approach be sensitive to market-specific linguistic or visual trends?
Thanks, Shivam, for your question. So to the first question, so if the if the embeddings from the ML models were completely divorced from consumer behavior, right? So if they didn't capture anything about how consumers perceive the world, we wouldn't find the results that I showed, in the experiment, for example, where actually we find that those embeddings are predictive of how consumers choose, right? So that is exactly the validation. The reason we did the validation because we wanted to see if there was signal in this data, right? And we're not saying that the machine is perfectly aligned with the humans, but there is seems to be pretty strong signal there about how consumers behave. So even if there are some kind of algorithmic biases, the embeddings obtained via the ML models do seem to be predictive of consumer behavior. Your second question was about consumer trends. Did I remember correctly? So we really don't explore the time dimension as much in the sense that all of the embeddings that we're obtaining are essentially at one point in time, right? So there's no sense in which we capture, we see how let's say the product descriptions evolve over time. In fact, we're actually in the process of looking at that because we're actually interested in sort of for example, sellers adjusting the way they describe their products or the images that they use to advertise their products depending on the underlying demand conditions, right? This is something if that was happening, we would want to account for that. We seem to right now, we're finding quite a lot of stability in these descriptions and product titles and images over time. But for sure, one could imagine sort of over a longer time span trying to infer something about how consumers' perceptions or preferences evolve from the way in which the products are described on, let's say, an e-commerce platform, right? Or from the descriptions, the images that are being used to showcase the products.
Yeah, thank you, Dr. Compiani. So, Dr. Gui, if I may ask a question with the context of contextual variable influence on causal inference, given that LLM-based simulation often unintentionally use control variables as salient reference points, how do you propose we distinguish between variables that should remain constant and those that LLM inherently adapt to? And would a structured causal model explicitly defining treatment and covariates mitigate this issue? Or are LLMs inherently biased towards certain associative patterns due to their training data?
Yeah, I think that's a great suggestion in terms of whether like the structural model, like the structural causal model, where that gives a clear definition of what is the treatment and what is the covariance. That certainly helps, because like one of our like message is that as long as you have some ambiguity, and using simulation like has a lot of room for ambiguity, it can like compromise your results. So being clear on the treatment and the covariance can definitely help. But also like we also want to be clear about like what is the exact like environment, what is the exact setting, and for the covariates, not only whether they're used as a control, but also are they supposed to be something that the customers pay attention to, or not? So like also about the customers like decision environment. So that is also something that is helpful to clarify. And of course, like one way to do that is to like incorporate more information in the prompt, but also is useful to think about developing models that are better at processing those informations and distinguishing different kind of variables. So it's like the development of prompting, and also the corresponding model that is better at processing those information in a very precise way, that like fits into like what researchers are interested in studying.
Yeah, thank you, Dr. George, for your insights. Uh, and the next question is for Dr. Kim, with the context of long-term and spillover effects of unionization. So your DID designed controls for selection bias, but have you examined the long-term effects? For an example, does customer satisfaction recover over time, or do negative perceptions persist? Additionally, could non-unionized stores experience spillover effects such as managerial adjustments or competitive responses impacting customer sentiments?
Yeah, thank you for the question. So we think it's a little bit too early to talk about some like long-term effects, because as I said, the first unionization movement occurred in 2021, and there were like a number of stores that were unionized in like 2023 and so on. So I think it's not like long enough time has passed. But we believe that there could be the long-term effects. For example, like you said, the customer sentiments could go back to the previous point, and also the non-unionized stores can get some spillovers because like it's even the non-unionized employees can observe like what's happening to unionized stores and what's the managerial responses and things like that.
Yeah, thank you, Dr. Kim. Another question for Dr. Compiani. Your experiment designs validate the model by predicting second choice selections after removing the first choice product. While this demonstrates robustness, consumer preferences often evolve dynamically in real world settings, influenced by, suppose, a new product launches, its marketing campaigns, and seasonal variations. So, how does your approach accounts for temporal shifts in consumer demand? And do you foresee any limitations in applying this model to industries with rapid product turnover, such as fashion, which you mentioned, or consumer electronics?
Yeah, no, great question. So the experiment is very much static because we basically ask those, both questions in a matter of minutes from each other. So we don't expect a lot of, changes in consumers' preferences over that time span. But more generally, yes, we would definitely want to allow for some flexibility over time. An easy way to sort of incorporate some, trends in consumer preferences would be to just have some fixed effects inside the model, right? Some time fixed effects or time product fixed effects that would capture sort of that kind of variation. Maybe some products being particularly, again, trendy or fashionable in a given moment in time. So I think that would be sort of the kind of fairly easy way of doing this. Changing consumer. So this is like one approach. The other would, maybe part of your question is also like maybe the way in which consumers value certain specific features of the product, right? Like maybe whether a dress or whether a shoe has a certain color becomes suddenly more important because it's the kind of shoe that everyone has. So that would be basically in our model would be captured by our random coefficients. So the coefficients on our embeddings kind of varying over time with enough data. If you observe a panel of people, sort of a long enough panel of several people, of a large enough cross section of people, that could actually be done as well, sort of having that kind of heterogeneity over time. And I agree that this, particularly for products that have sort of where preferences evolve quite rapidly, it would be, or dramatically would be quite important. Last thing I want to say is that the point about new products, this is actually one of the uses of the model could potentially be, simulating and predicting how consumer choices would change if a new product was introduced, right? This is exactly one of the uses of a model of demand. And so in that sense, assuming that the mapping from the product text and images to embeddings is kind of stable, the model could be used to answer that question.
Thank you so much for your answer. So we would now like to take few questions that audience have raised. So one is question to Professor Minkyung by Tejasvi. So he asked you about, did you consider satisfaction as quality, unlike SurveyQL? What about these self-selection of users not to post? How would the quality be evaluated in that way? And also the quality offered by Starbucks is constant. Shouldn't it be sampled from a distribution point?
Okay, yeah, thank you for the questions. So first, we like you could see from the presentation, we measured the customer satisfaction only based on the reviews and Google reviews, and also we measured this customer satisfaction on each attribute. And the second question is, yeah, we acknowledge that the self-selection in review participation could like that's what we could not really fully address because we do not observe those customers who actually made the purchase from the Starbucks stores but did not post any review, and their kind of like sentiment level might be different for unionized stores and non-unionized stores. So what we tried to partially address that issue is we kind of like compared the number of reviews before and after this treatment or the unionization movement. And also we compared those numbers to store footfall data that we got from the third-party source to see if the ratio of the ratio between the number of the reviews and the number of footfalls dramatically changed or not. And we did not see a dramatic change like between those like treated and the control stores, and also across the time. So we thought the self-selection issue is not a huge like driver of this result. And the last question is the quality offered by Starbucks is I think constant or not, like depending on like how you define the quality. So our analysis shows that the food quality or the kind of the store ambience or things like that did not really change over time before and after the unionizations, but the service quality, like measured by the employee friendliness and employee behavior, changed a bit. And it could be driven by a number of factors, which is not the scope of our paper. And I think I want to address one more question before that, which was asked by George Sebastian, like right after my talk, that the Starbucks store data for unionization is not adding up. So I think his point is that I gave the number of stores that filed to unionize and the number of stores that got unionized and did not get unionized. So those numbers do not match up. So I did not give specifics about this institutional setting, but there is some like time gap between the filing for unionization and the elections. So that's why that we see like more number of stores filed for unionization than the number of the stores that were voted in favor or were voted in against. Thank you for the questions.
Yeah, thank you, Dr. Kim. And I think the next question can be answered by both Dr. George and Dr. Kompiani. So the question is that by Samirit, with the rise of AI LLMs being trained on AI generated data as sources of human generated data goes dry to train LLMs, do you foresee a noticeable change in artificial persona synthesis, and what kind of challenges can we expect? So, Dr. George, let's start with you.
So, I mean, like the generated data to be used as a training data for future models. That's definitely like a question, like a very important question. And the question is whether if there are some biases, whether the biases will like propagate for future models. And in terms of whether that is going to be a challenge for the simulate human behavior, I feel it's like always important and like even more valuable to get the validation data and use the actual human data to facilitate the training. And like like for example, for firms and for researchers, like if they have some access to certain data about actual human behavior, then it's even more valuable and important.
Yeah, Dr. Kompiani, your take on.
Yeah, I would agree with this. It's there is definitely a lot of talk and a lot of hype about sort of using this type of LLM generated data. But what I took away from George's presentation is that this can be very challenging, and in a way, ultimately what we are all trying to do is to capture human behavior. So maybe there is a way in which LLMs can allow us to make better use of the data that we have, the human data that we have. But I think there will always have to be at least a part of our data that comes from actual humans, because that is exactly what we're trying to predict. So I do not foresee a scenario where the entirety of an analysis is based on artificial data, because I do think that would run the risk of being quite divorced from the ultimate goal.
Yeah. Thank you, Dr. Kompiani, and thank you, Dr. Gui, for your answer to this question. We have many more questions, but as we are overshooting time, it has been a pleasure engaging in this insightful discussion. We explored AI's integral role in marketing and market research, for example, in optimizing ads, customer feedback, and personalizing recommendations. Our panelists have provided invaluable insights on AI's impact in online search, advertising, highlighting both opportunities and challenges in the digital landscape. May I now request Mr. Venkatesh to formally close the seminar?
Thank you, Shivam. And thank you, Dr. Kim, Dr. Kampiani, and Dr. Gui. It was a pleasure having you here, and your insights into unionization, demand estimation, and the simulation of human behavior are very different and were very well received. The fact that many people are still active participants, considering that time in India is a testimony to how interesting the discussions were. And we look forward to opportunities where we could host you in person. And please let us know for any future opportunities. And all the participants, thank you very much for your active participation and the very good questions. And Shivam, as usual, you've been a great moderator and look forward to sessions with you as always.